Hi, I am Rudelyn Rabago. I will be discussing the first few slides. Its meaning, why we should use ER diagrams, facts, history, symbols, and notations. Right after this intro, without further ado, let's begin.
What is entity relationship diagram?
According to Guru99.com, ER diagrams or entity relationship diagrams are diagrams that display the relationship of entity sets stored in a database. Best example is the picture. Don't be confused of what the pictures means. We will go it through in the next minutes of this video. ER model is just like flowcharts or any other visual models you've seen, but what makes it high level is it systematically analyzes data requirements to produce a structured database. So what's the connection between the two? So the man who proposed the AR diagram is no other than Peter Chin. He proposed this for relational databases and networks and as a conceptual modeling approach. According to Internet, diagrams helps you to define such terms related to entity relationship, gives you what the fields must be inside that table, helps you to build databases quickly, will give you a blueprint way as a databases designer. Much likely to help you if you plan or are currently a database designer to have understanding of what should be contained in a database and give you a chance to connect with the logical structure of the database to users. Four facts are model that allow you to draw databases design, an easy to use graphical tool for modeling data, is popular or widely used. It's a GUI representation of logical structure. Just like flowcharts in Programming 101, in database, we have what we call ER diagrams, symbols, and notations. So there are the shapes with its So these are the shapes with its assigned representation. Rectangles represent entity types, ellipses for attributes, diamonds for relationship types. Lines represent that it links attribute to entity types and entity types to other relational types. Primary key, however, are attributes and underline the double ellipses represent multi-valued attributes. The picture showed the detailed representation of these symbols. Okay, that's all for these few slides. See you next reporter. Bye bye.
Hi, I'm Michelle A. Macahis. I will be discussing ER components, strong and weak entity set, and cardinality right after this ad.
You didn't have to cut me off. I got you, homie. Let's go.
As you can see, ER models or diagrams are based on the three concepts: the entities, attributes, and relationships. Why? See the photo as your reference while I'll explain it. As you can see, entity is defined as the person, place, object, event, or concept that data must maintain. Best example of entity are student and car, while attribute is defined as property or characteristics of an entity. In the photo, the name of the person and color of the car, Jack and Blue. Relationship is simply the connection of the two. Blue car belongs to the student Jack. In simple terms, what defines name is attributes. The place or object or person is entity. Simple as student Michelle. Student is entity, Michelle is attribute. The photo shows more than one entity and attribute in each entity. Here's the comparison between strong and weak entity set. Strong has primary key, weak doesn't have. Strong represented by a rectangle symbol, weak is a double rectangle. Strong has primary key represented by underline symbol, the weak has partial key represented by dash underline symbol. The member of a strong is called dominant entity, while the other is subordinate entity set. In strong, primary key helps to identify its member, while weak has combination of primary and partial key. If two strong entity is shown using diamond symbol, while if one strong and one weak shown using double diamond. Connecting lines for strong is single lines, while the weak uses double. Cardinality is used or seen when numerical attributes of the relationship of two entities or entity sets are considered. There are four relationships: one-to-one, one-to-many, many-to-one, and many-to-many. One-to-one means, let's assume this is entity, set student, and entity set course. Entity set student is associated or has relationship or connections at most 1 to course and vice versa. Another real-life example of a one-to-one relationship is a passport for one person, or one person has one ID number, or ID number is unique to one person. A person owns a dog and the dog is owned by the one person. Look at the line. There is one vertical line at the left and two at the right. One-to-many means, let's assume entity set class and entity set student. Class can be associated to student in many ways, but student cannot be associated to class in many ways, or in simplified way associated at least one. A real-life example of that is a car maker makes many different models, but a particular car model is built only by a single car maker. Or one customer may make several purchases, but each purchase is made by a single customer. Look at the line. It has three short lines pointing to the entity set triangle. Many-to-one is a reverse relationship of one-to-many. A real-life example of that is multiple employees working under a single manager in a company. This is a many-to-one relationship where the entities involved are the employees and manager. Look at the line. Same as the one-to-many, but entity sets are reversed. Many-to-many is simple or closer to how one-to-one is defined. It is the entity set X and Y is associated with more than one entity and vice versa. A real-life example of that is your order table contains orders placed by multiple customers who are listed in the customers table, and a customer may place more than one order. Look at the cardinal signs. It is triple short lines with a vertical line. Always remember that every cardinal relationship, as this would help you in any relational purposes. Okay, that's all for these few slides. See the next reporter. Bye-bye.
Hi everyone, I am Lhara Tejano. I will be discussing how to create an entity relationship diagram or ERD right after this ad.
Few moments later.
As you can see, there are 5 easy steps to create an ER diagram. First step is entity identification, followed by relationship identification, cardinality identification, identify attributes, and lastly, create ERD. Let's assume we're in a university. A student enrolls in courses. A student must be assigned to at least one or more courses. Each course is taught by a single professor. To maintain instruction quality, a professor can deliver only one course. From this situation, we can conclude we have three entities: the student, course, and professor. That's the time we can say the first step has been applied. And then second step, inserted by showing that there are relationships between the entities. The student is assigned a course and professors deliver a course. As you can see, this is now another symbol or shape. The diamond, which as discussed by Ate Rudelyn, means relationship types, which is assigned and line means they are linked to each other. The third step is cardinality identification. That is when a problem exists. Here, we will apply that we have learned from Ate Michelle that cardinality is used based on the problem or situation given. In the picture shown, it uses many to many and one to one, which in the situation we assume. A student can be assigned to multiple courses and a professor can deliver in one course. So the fourth slide, you need to study the files, forms, reports, data currently maintained by the organization to identify attributes. You can also conduct interviews with various stakeholders to identify entities. Initially, it's important to identify the attributes without mapping them to a particular entity. Once you have a list of attributes, you need to map them to the identified entities. Ensure an attribute is paired with exactly one entity. If you think an attribute should belong to more than one entity, use a modifier to make it unique. Once the mapping is done, identify the primary case. If a unique key is not readily available, create one. So to simplify the explanation I had said, primary key is a collection of attributes or a single attribute that has the capability to uniquely identify records in the table. The attribute is a characteristic of an entity or table. So the last step shows the final creation of ER diagram. So okay, that's all for these few slides. See the next reporter.
Hi, my name is Ralph Joseph Vios. I will be discussing best practices for developing effective ER diagrams.
Okay.
First is eliminate any redundant entities or relationships. We all know that if we have made duplication on our codes or as a database designer, our data are complicated. It will lead to confusion and distraction. Second is, you need to make sure that all your entities in relationships are properly labeled. We all know that if you label the things before you meet into a code or a program, a very good practice is dealt with. And the third is, there may be various valid approaches to an ER diagram. You need to make sure that the ER diagram supports all the data you need to store. In this practice, you will never leave anything hanging or mess up. So this is the most important thing to note with. The fourth is, you should assure that each entity only appears a single time in the ER diagram. Just like the first practice, if we use ER diagram, we might somehow avoid duplication and the entity appears maximum of once. And the fifth is, name every relationship entity and attribute are represented on your diagram. This could be one of the most to note with also, as you have to, just like the second practice, you have to label. And the sixth is, Never connect a relationship to each other. A heads up to all database designer or user that will make use of ER diagrams or relational database to note this. Never connect if not relatable. And lastly, you should use colors to highlight important portions of the ER diagram. Let's assume that all programmers or database or relational users are color advantaged. Using this practice will help them mostly to cover up the fields of each disadvantaged person. Somehow, doing this practice will help them according to some research. So as you can see in the picture, there are plenty of wrap-ups. To simplify this in 5 wraps, first is entity relationship diagram is also called ER diagram. ER model is a high-level data diagram. In DBMS, our blueprint of database as discussed by Ate Rudelyn, it is based on 3 basic concepts: entities, attributes, and relationships. And lastly, ER diagram, DBMS is a visual representation of data that describe how data is related to each other. Oops. There's a recap of what ERD is. Please see video, it will be 3 minutes.
In the world of database management, entity relationship diagrams, or ERDs, show how entities, such as people or things, relate to each other. So relationship is what we're talking about. In our case, we're looking at the relationship between tables and our databases. And tables are going to be our entities. So the relationship between those entities or tables. So here's an example. Let's say we have a table or an entity, professors, and then another table or entity which is classes. And the ERDs can show us the relationship between these tables. Now to read this ERD, let's break it down a little bit. So the first, we've got our entity here. That's professors, or a professor in this case. And then a key in our table, we could have primary keys and foreign keys across our ERD. We have fields. So for each of these entities, we have fields that describe them. So there's a unique identifier, a name, an email, there could be more, and then also the data type for those fields. And then finally, we have a relationship. We're showing the relationship between these entities. It's an entity relationship diagram, and that notation, which in this case we're using what's called crow's foot notation. We'll talk more about what that means, but that is showing us a relationship between these entities or tables. So here's an example. We're going to just build on this, and we're going to read here from left to right. And we'll use the notation on the right, though. So professors can teach 0 or many classes. That's the relationship here between these entities or tables. And that notation that's highlighted, it just means, again, 0 or many. Now, if we read this in the other direction, what we say is that classes are taught by one and only one professor. That's what the notation on the left means. So it shows us the relationship between these entities or tables. Now let's build on that a little bit further. Let's talk about departments. So professors are part of departments. So let's read this from top to bottom first. So professors are in one and only one department. They can't be in multiple departments. And then the departments, if we're going from bottom to top, these departments have many professors. So we're not using 0 or many, because what we're saying here is the departments have to have multiple professors in them. We're not going to have a department without any professors in it. Okay, so when we're showing these relationships, we're calling that cardinality. And the most common way to show that relationship or that cardinality is using crow's foot notation. So here's the different possibilities we can have. 0 or many, which is what we talked about. Another option or similar option is 1 or many, or just many if there has to be more than one, multiple. We could also have 0 or 1, 1 and only, and 1. Don't worry too much about the distinction between 1 and only 1 and 1, Most often, we're using one and only one, and sometimes people get confused about those distinctions. So anyway, we focus on the ones at the top here typically. Thanks for watching. If you like this video, click the subscribe button. And if you're interested in a SQL cheat sheet, you can find one over at codybaldwin.com.
That's all. Thank you guys. Bye bye.